Okay, so question number 5. Choose the wrong statement about intermolecular forces. So for A, the attractions due to the induced dipoles and instantaneous dipole results in London dispersion forces. Okay, so A is actually correct. So London dispersion forces are caused because of this temporary attraction when the dipoles are induced, and it actually takes place in all molecules. So let's look at B. The weakest force of attraction among the intermolecular forces is van der Waals forces. So this is true as well. C. Dipole-dipole attractions are seen in polar molecules. So this is true. So let's have an example of dipole-dipole attractions. So let's say we had a water molecule. So this is the structure of water. It's H2O, and it has a bent molecular shape as well. And this is because of the lone pairs on our oxygen. So it kind of has this bent shape. Also, oxygen is much more electronegative compared to hydrogen. So we can draw a dipole moment going towards the direction of the oxygen. So this causes a partially negative charge for our molecule and a partially positive side of our molecule as well. And when we have like this polar molecule that has a partially negative and partially positive side, it can attract a different polar molecule that also has a partially negative and partially positive side. And this is known as dipole-dipole interactions. So here I'll draw another water molecule. That. And this can occur with all polar molecules, so that's why when we try to figure out if a substance can dissolve in another substance, we use the term like dissolves like. So polar molecules can dissolve other polar molecules, and non-polar molecules can dissolve non-polar molecules. So now let's look at D. Hydrogen bond is not an intermolecular force, attractive force, in which hydrogen atom bonds to electronegative atoms of same or different molecules. So this is our false answer. So hydrogen bond is an intermolecular attractive force. And I can show how hydrogen bonds occur. So this is again, that partially positive hydrogen can be attracted to the partially negative oxygen of a different polar molecule. And that's how like water molecules like stick together because of this attractive force. So it's important that the hydrogen needs to be bonded to another electronegative atom in order to have that kind of force. So like when hydrogen is bonded to chlorine, again we'll have a net dipole moment towards the chlorine atom since it's much more electronegative. This hydrogen will be partially positive, the chlorine will be partially negative. And if we had another atom of HCl, then we get hydrogen bonding as well. Okay, so the answer is D. This is the wrong statement about intermolecular forces. So the junior tutor said that A is correct. London dispersion forces are temporary attractive forces that occur when the electrons in two adjacent atoms occupy positions that make the atoms form temporary dipoles. B is correct. Van der Waals forces are indeed the weakest of intermolecular forces and exist between all types of molecules. C is correct. Dipole-dipole attractions are indeed seen in polar molecules, wherein the attractive forces occur between positive end of one polar molecule and the negative end of another. This occurs because of the uneven distribution of electrons within the molecule. Finally, D is wrong. A hydrogen bond is an intermolecular force of attraction that results from the attractive force between a hydrogen atom covalently bonded to a very electronegative atom, such as nitrogen, oxygen, or fluorine. Yep. So this solution is correct.